let's work with some landmarks. This is the file that you can download from Brightspace for the Foundation Year project. And it's got the anonymous numbers corresponding to each of the foot images, and it's got 12 landmarks going along the top. Okay, so all I've done is I've copied the first 12 landmarks, so all the way to there, all the way from there to, let's get it right, to there. Okay, and I've copied that and I've pasted it into a sheet. I've used the insert column to add a column, and then I've gone through looking at the data that everybody contributed and classified it males, females. Now there are a lot of rows that people had chose not to identify with a gender, or we just had more footprints than we had people that did that part of the exercise. So I've deleted that and cleaned up the data, so I've got this data. Okay, so I've got landmark 1, which was a heel, an X and a Y point. And we're going to pause in a minute and I'll show you what those landmarks actually mean. Bing. So we understand what the landmarks mean. Okay, so the next step that we've got is to then think about how we can superimpose all of these different tracks that are in one common frame. So how are we going to do that? Well, we're going to use this program called PASS, which you can download from the free. So you put PASS statistics into Google or Chrome or whatever you use, and it will download it. Okay, we're going to the top, and we're going to open up those extra attributes. Right, so that's what we're going to do, and we are just going to go, what are we going to do? We're going to go all the way from there to there, copy it, Command and C for copy, and we're going to call this up, and we are going to put it in there, like that, paste it in. Now we know they're X, Y, X, Y, so we're just going to simplify it life for us a little bit. So by just getting rid of the top 2, edit, remove. Okay, and we're going to call column A, we're going to call it a group. And now the program knows that this is going to split all our data by males and females. All right, so highlight the lot and plot an XY graph, and oh, what a mess that looks. And that's because every footprint that we've got in the data set has a different origin and a different orientation. They don't have the same coordinate set. We've got to solve that. So how are we going to solve that? Well, we're going to solve that by going to transform landmarks Procrustes. And Procrustes is this way of transforming spatial landmark data, so it all comes into the same axis, and it also removes size. You could keep size in, but we're going to remove size. So press OK, and suddenly we get lots of numbers like that. Plot XY graph again, and look, we're doing really well now because we've got things that make sense. And if we put the landmarks in, these circles are 95% ellipses. So 95% of, it's showing you the area that 95% of the data corresponds to. But these are all outliers. And sometimes when you're placing landmarks, you can really make mistakes. So the chances are these are mistakes, okay? And there's something a bit odd. So if we use labels, we can see that it seems to be row 51 and row 14 that seem to be giving us the problem. So let's go out. Row 14, was row 14, edit, remove, and then basically 51. There we go, 51, edit and remove, and we should now have data. So we're also just going to perform the procrustes again because we are slightly different, the data. And then when we come out, there we go. It looks a lot better, doesn't it? Hugely better. Right. So that's good. All right. So how can we tidy this up and go to the next level? Well, this is quite a difficult program to use sometimes. So what I'm going to do is I'm going to pick another color. What should we have? Let's have a red color. Slide that down there. What shall we have? We'll have a nice pink for men, just to be different. Okay. So that's black, that's pink for M. Now we could do that manually, but what I'm going to show you is a little trick. So go into there, copy the whole data set, call back our Excel spreadsheet, open a new one up, and paste it all in. So what are we going to do? So let's just get rid of those top rows. So delete, and let's do a special sort. So sort, custom sort. We want it to sort on column D. So column D, and A to Z will do. And so it's given us all the females first and the males at the bottom. Okay, so this is it's a hex code for the color. And if I paste it in there, okay, and I drag that all the way down there, I have colored them in really quickly. Okay, we're doing really well now. So that should work. Everything's ready. Now I'm going to do one other thing at the bottom here. I'm going to say average M, and I'm going to go average female. Okay, so we're going to equal average. There we go. Average, those are the men, so let's just put the males in there. Okay, and a return. I'm going to drag that all the way across, and that's just averaged all the male landmarks, okay, across. So our next job is to go equals average, and we're going to do the females now. So the females all the way to the top, okay, and copy it across. Okay. And then what else am I going to do? I am going to, well, that's my male symbol, so I can just, hold on. Got that down, and then I want to copy this one, which is the black. Copy from the female. All right, so let's just call that 105 and 106. All right, so I'm now ready to go back. So let's call back up this. I'm going to go File, New. It's going to ask me, do you really want to delete that? And I do. Okay, open up the row attributes and everything again. Go back to my Excel spreadsheet. Good. Copy here. And where do I want to paste it? I want to paste it there. Okay, so reset that up as group. Okay, so I should now, if I've got it right, and it's always uncertain whether you got it right, I should be able to plot X, Y, and graphs, and there we go. For some reason, it's given me some strange colours. Let's just see. Yeah, I don't quite know why I've got green in there, but something must have gone wrong in me copying the colours across. But let's just live with that for now, okay? We could live with that. I'm sure we can live with it. What happened? Oh dear, right. So, yes, well, there you go. We all make mistakes, don't we? So, where's my mouse? That's the colour I actually want. and I want it all the way down to there. Okay, so we'll just copy that and see whether we can correct that. Fix that now, and it's all pink. The reason that it didn't work was the fact that basically Excel was adding a number to my series as it was copying it down. Anyway, it's sorted now, so let's go back, plot XY graph, there it is, and we've got the differences. Okay, so make it a bit bigger, there we go. Put me 95% confidence ellipses on, and that's the difference, males to females. There's still some outliers, but we're going to leave those. So what can I do? Well, if we go back down here to pick up these two, these are my averages, okay? All right, and we'll go to geometry, landmarks, thin plate splines. And a thin plate spline is this, like this sheet of rubber. Okay, so we'll make it colourful. All right, and let's increase the number of grid squares. Let's go to 30. Okay, now if I compare 105 with 106, okay, this is what you have to do to the rubber sheet to make the landmarks average for men fit the average landmarks in females. And you can see a bit of a distance here. So there's an expansion, the red colours. These points are moving apart. Not much, but a little bit. And here, they're contracting. So we can see that there's differences around the toe, the difference between the first and second toe, and around the heel that separate our males and females. It's very, very subtle, though. But that would be the purposes of thin plate spline. Okay. Those are my bits. There's my thing. The vectors are like little tails which show you the directions, but they're not showing up very much there. All right, so what else could I do? So the other thing that I can do is I can do a landmarks and a principal components analysis. Okay, and this is looking at all the landmarks. It's trying to find out new data. There we go. So about 30% of the variance is by the first component, 15 or 16 by the second component, about 10 by the third. Let's have a scatter plot. Okay, so the horizontal is the first component, the vertical is the second component. So the first thing, you can see them here. And the first thing that you can see is that they overlap. We're not getting a separation in terms of shape that really is very different. They seem to be the same. So let's set that idea aside, okay, and let's look at what is giving us that variation. What is the shape change along that axis? We want to go from, say, 0.05 to minus 0.5. So let's look at the shape that corresponds to this point and to that point. So deformations, okay, so we want PC1, we want the expansion factors, and let's put in 0.05, okay, so that's the negative side, all right, negative 0.5, and you can see that it's the change in the instep, how flat the foot is, how well developed the arch is. And if we go to the positive version, again, it's this area. So this is the key difference that is explaining the change on this axis. So let's go back to our deformations, and it's about, what, 0.5 to 0.5 again. So let's put the second component in and see what's varying there. So 0.5, oh, it seems to be something to do with the spacing between the little toe and that width marker, how much space there is. So I suppose the angle that the toes come down. Let's look at it. Negative, yeah, we're still getting a bit of heel. So that would be a way of analysing the data and seeing how it varies within the class. What else can I do? I can go to graph and I can export them as SVGs. That's scalable vector graphics. So I could export that diagram. I could export my vectors, SVGs, and then assemble all of those bits of data into one place.